The complete history of artificial intelligence, from ancient dreams to superintelligence. The invention that could change everything, artificial intelligence, seems to have arrived overnight. One moment, computers were tools. We typed commands, clicked buttons, and told machines exactly what to do. Then suddenly, machines could write, create images, recognize voices, translate languages, write computer code, help discover medicines, and hold conversations that sometimes feel remarkably human. But AI did not begin with ChatGPT. It did not begin with Google. It did not even begin with the computer. The dream of creating artificial intelligence is far older. For thousands of years, human beings have imagined something extraordinary, a machine that could imitate the mind of its creator. And the journey from that ancient dream to today's artificial intelligence is one of the most fascinating stories in human history. Before computers, there was the dream. Long before electricity, people imagined artificial beings. Ancient Greek mythology told stories of Hephaestus, the god of craftsmanship, creating mechanical servants. One famous myth described Talos, a giant bronze guardian that protected the island of Crete. These were myths, not artificial intelligence. But they revealed something important. Human beings were already imagining artificial entities capable of acting on their own. Over the centuries, inventors tried to turn pieces of that imagination into reality. Ancient and medieval engineers created automata, mechanical devices that could move through systems of gears, water, weights, and pressure. By the 18th century, European craftsmen were building extraordinarily complex mechanical figures. Some could write. Some could play musical instruments. Some appeared almost alive. But these machines could not think. They simply followed mechanisms created by humans. The missing ingredient was computation. And in the 19th century, that began to change. The machine that could have become a computer in the 1830s. British mathematician Charles Babbage designed something astonishing: the analytical engine. It was never fully constructed in his lifetime, but its design contained concepts recognizable in modern computers: memory, processing, input, output, and programmable instructions. Then came Ada Lovelace. While studying Babbage's machine, Lovelace saw something deeper. A calculating machine did not necessarily have to work only with numbers. If other things, such as music, could somehow be represented symbolically, perhaps machines could manipulate those symbols too. That idea was revolutionary. A machine might one day do more than calculate. It might manipulate information. But the technology required to build such machines at scale did not yet exist. Humanity would have to wait another century. Alan Turing asks the question. Then came World War II. At Britain's Bletchley Park, mathematician Alan Turing played a major role in the effort to break encrypted German communications. But Turing was thinking about something much larger than wartime cryptography. In 1936, even before the war, he had described an abstract mathematical model of computation now known as the Turing machine. Then, in 1950, he published one of the most important papers in the history of computing. Its title was Computing Machinery and Intelligence. It opened with a provocative question: can machines think? Turing knew the word thinking was difficult to define. So he proposed a practical experiment, later popularly known as the Turing test. Imagine communicating through text with two hidden participants. One is human. The other is a machine. If you cannot reliably determine which is which, could the machine be considered intelligent? The philosophical dream of intelligent machines was becoming an engineering problem. Artificial intelligence gets a name. The decisive moment arrived in 1956. At Dartmouth College in the United States, researchers gathered for a summer project built around a bold proposal. John McCarthy, Marvin Minsky, Claude Shannon, Nathaniel Rochester, and other researchers associated with the emerging field believed aspects of intelligence could potentially be described precisely enough for machines to simulate them. The proposal used a new term, artificial intelligence. AI finally had a name, and confidence was enormous. Early programs could prove mathematical theorems. Researchers developed systems that played games. Arthur Samuel's checkers program became an influential example of a machine improving its play using experience. Alan Newell and Herbert Simon developed programs such as Logic Theorist. The possibilities seemed unlimited. Some researchers believed human-level machine intelligence might arrive surprisingly quickly, but they had underestimated the problem. The first great failure, early AI worked well inside small, controlled worlds. But reality was different. Language was ambiguous. Vision was complicated. Common sense was enormously difficult to encode. Computers were expensive. Memory was limited. Processing power was tiny compared with today's machines. And researchers did not have today's enormous digital data sets. The promises had become much larger than the results. Governments and funding agencies became disappointed. During the 1970s, funding declined in important areas. AI entered what became known as an AI winter. Interest would return. Expert systems became commercially important during the 1980s. These programs attempted to capture specialist knowledge through large collections of rules. Companies invested heavily. AI was back. But maintaining enormous rule systems was difficult and expensive. The market again became disappointed. By the late 1980s and early 1990s, another AI winter had begun. Many people thought the dream had failed. But AI wasn't dying. It was changing. Machines learn instead of being told. One of the most important changes was a shift in emphasis. Instead of trying to manually program every intelligent rule, researchers increasingly developed methods that allowed computers to learn patterns from data. This became the modern world of machine learning. The basic idea was powerful. Don't tell a computer every possible rule for recognizing a cat. Show it examples, and develop an algorithm capable of learning useful patterns. Artificial neural networks pushed this idea further. They were loosely inspired by networks of biological neurons, although they were mathematical models, not artificial brains. The ideas behind neural networks had existed for decades, but they faced a problem. They needed computational power and large quantities of data. Then the world accidentally created both. The internet becomes AI's fuel. During the 1990s and 2000s, the digital world exploded. The World Wide Web expanded. Search engines appeared. Digital cameras spread. Smartphones arrived. Social media grew. Businesses digitized enormous amounts of information. Humanity began generating data at a scale never seen before. At the same time, computer processors became dramatically more powerful. Graphics processing units, or GPUs, originally developed primarily for graphics, proved extremely useful for the kinds of parallel calculations required by neural networks. The ingredients were finally coming together. Better algorithms, more computing power, and enormous data sets. Then, in 2012, something happened that shocked the computer vision community. The deep learning explosion. A neural network known as AlexNet entered the ImageNet large-scale visual recognition challenge. Developed by Alex Krzyzewski, Ilya Sutskever and Geoffrey Hinton. It dramatically reduced image classification error compared with competing approaches. The result became a landmark moment for deep learning. Suddenly, neural networks were no longer an obscure idea waiting for better computers. They worked at scale. Technology companies accelerated their investment. AI became increasingly capable of recognizing speech, classifying images, recommending content, translating languages, and detecting patterns hidden inside massive datasets. But another revolution was approaching. When machines defeated champions, AI's progress had already produced spectacular symbolic victories. In 1997, IBM's Deep Blue defeated world chess champion Garry Kasparov in a match. It was a historic moment. But chess was only the beginning. In 2011, IBM Watson defeated elite human champions on the television quiz show Jeopardy! Then came Go. The ancient board game has an astronomical number of possible positions. For years, many experts believed top-level Go was beyond the reach of machines. Then, in 2016, Google DeepMind's AlphaGo defeated legendary player Lee Sedol 4-1. One move became especially famous. Move 37 of Game 2. It initially appeared strange to human observers, yet it proved brilliant. AI was beginning to find solutions humans might not naturally choose. Attention changes everything. Then came 2017. A group of Google researchers published a paper titled, "Attention is All You Need." It introduced the transformer architecture. Transformers were particularly powerful at learning relationships between pieces of information, and they could be trained efficiently at enormous scale. This architecture became foundational to the development of modern large language models. Models grew larger. Training data sets expanded. Computing requirements exploded. GPT, BERT, and later generations of increasingly capable models followed. Machines became remarkably good at predicting and generating language. And then, the technology escaped the research laboratory. The ChatGPT moment. On November 30th, 2022, OpenAI released ChatGPT publicly. The interface was simple. A text box. Ask something, and the machine responds. Write an email. Explain quantum physics. Generate computer code. Summarize an idea. Create a story. Millions of people who had never studied artificial intelligence were suddenly interacting with it directly. ChatGPT reached 1 million users within days. Generative AI became a global phenomenon. Other companies accelerated their own systems. Google developed Gemini. Anthropic developed Claude. Meta expanded its Llama family. Image, audio, and video generation advanced rapidly. AI was no longer simply recognizing information. It could generate new content. How does modern AI actually work? This is where things become strange. A large language model does not necessarily think like a human. At its foundation, it learns statistical patterns from enormous amounts of training data. During training, the model adjusts vast numbers of numerical parameters. It learns relationships between words, concepts, and structures. When you type a prompt, the system processes the context and generates a response by predicting sequences of tokens. Yet from that seemingly simple objective, surprisingly complex capabilities can emerge. Writing, translation, programming, reasoning-like behavior, pattern recognition, and increasingly, interaction with tools, images, audio, and software. But capability should not automatically be confused with consciousness. Today's AI systems can produce highly convincing language, without evidence that they experience the world the way humans do. And that distinction becomes extremely important when we consider what may come next. The race for the future. Artificial intelligence has now become one of the world's most important technologies. Technology companies are spending enormous sums on chips, data centers, models, and energy infrastructure. NVIDIA's GPUs became critical infrastructure for the AI boom. OpenAI, Google, Anthropic, Meta, Microsoft, xAI, and others are competing at extraordinary speed. Governments are also entering the race. The United States, China, India, European nations, Middle Eastern states, and many others all see AI as economically and strategically important, because whoever leads in advanced AI could gain enormous advantages in science, defense, medicine, manufacturing, finance, education, and economic productivity. This is no longer simply a competition between technology companies. It is becoming a competition over the infrastructure of intelligence itself. What happens next? And this brings us to the biggest question. Where is AI going? One possibility is artificial general intelligence, usually called AGI. There is no universally accepted definition, but broadly, AGI describes a system capable of performing a wide range of intellectual tasks at or beyond human levels. Beyond that lies an even more controversial possibility: artificial superintelligence. An intelligence exceeding humans across most important cognitive domains. No one knows whether such systems will exist or when. Predictions range from relatively soon to decades away, to perhaps never in the form people imagine. But even without superintelligence, today's AI could transform civilization. AI could accelerate drug discovery, help engineers design new materials, improve scientific research, automate parts of software development, personalize education, transform factories, change warfare, reshape creative industries, and automate portions of millions of jobs. That creates enormous opportunities and enormous risks. Misinformation, deepfakes, cybersecurity threats, bias, surveillance, job disruption, concentration of power, and the difficult problem of controlling increasingly capable autonomous systems. The next chapter is ours. For thousands of years, humans imagined artificial beings. Then we built mechanical machines, then calculating machines, then programmable computers, then machines that could learn, then neural networks, then systems capable of generating language, images, music, software, and video. The journey took centuries, but now the speed of change is accelerating. Alan Turing once asked, "Can machines think?" Perhaps the question facing our generation is different. What happens when machines become capable of doing more and more of the things we once believed required human intelligence? Will AI become humanity's greatest scientific tool? Will it transform work and civilization? Will humans and machines increasingly work together? Or will we eventually create intelligence that exceeds our ability to understand or control it? Nobody knows. And that may be the most extraordinary part of this story. We are no longer studying the history of artificial intelligence from the outside. We are living through it, right now. And the most important chapter hasn't been written yet. This is only the beginning.